All right, today we are going to look at, after we find our scale factor, how we can write that in an equation or using a rule. So let's go ahead and look at what we've kind of reviewed and talked about. So remember, dilations are exactly what similar figures are. However, it has to be an enlargement or a reduction. Because technically speaking, with a similar figure, you could have a ratio of 1, but you're just producing the same exact picture. So remember, dilations are using a scale factor, and we're going to use that letter K, and they are proportional. And as we've already talked about, that means that their ratios reduce down to the same thing. So the algebraic form, or we can call this the rule, of a dilation is on a point with a scale factor of K. So this will be your original point. So if we're starting at original point and we're going to the new ordered pair, well, we have X and Y as our original. So to find the new ordered pair, we're going to take the scale factor and multiply by its original X. And we're going to take the scale factor and multiply by the original Y so that we can get the new ordered pair. So basically what we've already talked about is now we can use this scale factor to predict future ordered pairs on a dilation. So remember, the scale factor for a reduction is going to be where K is less than 1 but greater than 0. So that looks a little funny like this, but if I said 0 is less than K, that means that K is greater than 0. So it's going to be between 0 and 1. So if that helps you, we can say between 0 and 1. Okay? So K is less than 1, but greater than 0. The scale factor for an enlargement is when K is greater than 1. Because if you multiply anything by a number bigger than 1, it's going to get bigger. If you multiply anything between 0 and 1, so 0.1, it's still greater than 0, and it's still less than 1, even 0.99 is in between there, okay? So it's going to get smaller because it's not one whole group. Well, a scale factor of 1 yields a congruent image. So that means nothing was dilated. It didn't get smaller and it didn't get bigger, okay? So let's keep looking at this. So 4 ordered pairs below, we're going to find the scale factor and we're going to write the rule using K. Then we're going to find new ordered pairs. So remember, just XY is the original. If I say KX, KY, this is using my rule to get to the new ordered pairs. Okay? So I'll show you what that looks like. So if they say I have a dilation of 4, that means that K is equal to 4. All right? So the rule is KX, KY. So N, K, and I are my original ordered pairs. So if I'm going to my new ordered pairs, I'm going to use KX and KY. So the K is my dilation. So here's what we're going to do. So N prime, the K is 4, and we're going to multiply it by its original X, which is 0, and my scale factor is 4, and my original Y is 0. Another way you can say it, think about it this way, 4X and 4Y. Well, all I'm doing is 4 times my original X, which was 0, and 4 times my original Y, which was 0. So then that means that N prime is going to be, well, 4 times 0 is 0, 4 times 0 is 0. Okay? All right, let's use different colors to help us out. Well, if K was 1, 1, well, let's think about the rule. K prime, well, my dilation of 4 means my scale factor is 4, is going to be 4x, 4y. So if I substitute that in, 4 times my original x For my k was 1, 4 times, because that's my scale factor. My original y for k right there is 1. So that means that k prime, 4 times 1 is 4, 4 times 1 is 4. So those are my new ordered pairs. Here again you can see 1 times 4 is 4. 1 times 4 is 4. So if that helps you to see it that way, you can go ahead and look at that. But this is the rule itself, 4x, 4y, every single time for this situation. So now if I have I, well I prime is going to be found by 4x, 4y. That's my rule. And all I'm doing right here is x. My original x was 1. And for I, my original y was 0. So then I can see that I prime, 4 times 1 is 4. 4 times 0 is 0. So these are my new ordered pairs for that first problem. Okay. Now I know a lot of you guys are going to try and do these real fast in your head, and you can. However, when they're asking you for the rule, this is what we're looking for. So the rule for this problem is 4x, 4y. No matter what your x was or what your y was, you're constantly multiplying by 4 because that's your constant of proportionality. This is your scale factor that you're multiplying by. Okay? So here again, look, 4 times 0, 0. 4 times 0, 0. 4 times 1, 4. 4 times 1, 4. 4 times 1, 4. 4 times 0, 0. So this is the rule itself for this problem. We put our scale factor in front of x as well as our scale factor in front of y, and these are your new ordered pairs. So you have to be very careful on what the question is asking, because we need to make sure that you're understanding. If they ask for the rule, this isn't the rule. If they ask for the ordered pairs, that's not the ordered pairs, that's how you're finding them. Alright, let's keep going and see how we can do these other two examples. Now, as we've already talked about, scale factors can be whole numbers like 4. They can be fractions, they can be percents, and they can be terminating decimals. They cannot be mixed numbers, and they cannot be repeating decimals. Okay, so if we were to think about this, we can multiply with fractions, or you can change it to a decimal, whatever makes it a little bit easier for you. So let's look at this. First, let's write the rule. Well, if they say dilation of 1/2, that means that your scale factor is 1/2 or 5/10. So you could say the rule is 1/2 x, 1/2 y, or you could say 5/10 x and 5/10 y. Literally means the same thing because 1/2 is congruent to 5/10. Alright, let's look at our first ordered pair. So x is -3, 3. So x prime, first we're going to write the rule, and I'm just going to use the decimals, 1/2 x and then 1/2 y. That's just showing my work. So 1/2 times my original x was -3 and 5/10 times 3. So that's going to yield x prime. Again, we can use our calculators if needed, or you can just think about what half of 3 is, right? Half of 3, think about money. So 5/10 times -3 is -1 and 5/10, because half of 3 is 1.5. But this one was a negative, and here again, think about half of $1. If you have $3 and you split it in half, you have $1.50. But just to prove it, 5/10 times 3 is 1.5. So that's my new ordered pair. And that makes sense. If my dilation is less than 1, then these new ordered pairs are going to be less than going to be shrunk down as a picture. Okay? So then my next one, let's do E prime, and I'll show the work over here. So again, we start with the rule, 1/2 x, 1/2 y, or 5/10, either way. So if I said 5/10 times my original x was -1 And 5/10 or 1/2, you could use either, times my original y, which was 4. We'll stop and think about it. Half of 1 is 50 cents, but a positive times a negative is a negative. So this would be negative 5/10. 5/10 or 1/2 is the same thing as dividing by 2. So half of 4 is 2. So again, you can use your calculator. I'm just kind of reviewing with you, because if you can do these things without calculators, it might help, but just again, double check with your calculator to make sure. Okay? So that way we can see it. So 5/10 times negative 1 is that negative 5/10, and 5/10 times 4 is that positive 2. And then our last ordered pair for t, just kind of using my work over here, so t prime, my rule is 5/10 x, 5/10 y. So now this is how I show my work. 5/10 times my original x was negative 3, and 5/10 times my original y for t was 1. So think again, half of a $3 is $1.50, but positive times negative is a negative. Half of $1 is 50 cents. So that should be my ordered pair for that. So t prime should be negative 1 5/10 times 5/10. Again, we can use our calculator to double check that we're right. So if we use our rule, we have 5/10 times the negative 3. That gets you that negative 1 5/10 for the new image. We have 5/10, which is my scale factor, times 1. And that gives you 5/10. My new image of my y is 5/10. So basically what we practice is if they've given you the picture, you can find the scale factor. But now they're saying, okay, well, if they give us the rule, the dilation, how much the scale factor was, we're now finding the ordered pairs. Okay? So just something to think about. So we are able to either find the scale factor itself, or when they give us the scale factor, find the new ordered pairs. So we've got to be kind of multidimensional to make sure we understand that. So let's look at one last problem together. So this one says the dilation of 1/4. Well, here again, if this is 1/4, that's in between 0 and 1. So I already know that I'm going to be having a reduction. So if I were to draw these, I could see that it's getting smaller. But I'm going to go ahead and change this to a decimal and say 25 hundredths. Okay? So that means that k is equal to 25 hundredths. So my rule is kx, ky, so it's going to be 25 hundredths x times 25 hundredths y. All right. So now let's go ahead and look at these. So we're going to look at one ordered pair at a time. So L is originally negative 5, negative 3. So if I want to find L prime, oh, I started with green. Let's keep it consistent for y'all. So L prime, we're going to start with our rule, 25 hundredths x, 25 hundredths y. Now I'm going to show my work. 25 hundredths times x, well, my original x is negative 5, and 25 hundredths times my original y was negative 3. So 25 hundredths times my original x, which was a negative 5, gives me negative 1 and 25 hundredths. 25 hundredths, which is my scale factor, times my original y, which was negative 3, gets me to negative 75 hundredths. So that's my new ordered pair. And then we used orange for the next one, so I'll just show my work over here. So V prime, we're using that rule, 25 hundredths x, 25 hundredths y. Basically, you're taking all of your original numbers given and you're taking a fourth of them, or multiplying all of them by 25 hundredths. Okay? But if they ask what's the rule, this is the rule for this situation. Again, it's different than this rule because it was a different scale factor. So 25 hundredths times, well, V's original x was negative 5. and then 25 hundredths times its original y, which was -1. So I have my work shown over here on the left. So I can go ahead and do my new ordered pairs. So 25 hundredths times the original x, which was -5, gets me -1 and 25 hundredths for my new x. And then 25 hundredths times my original y for v, which was -1, so I kind of got a little blurry. Well, anything times 1 is itself, but this was a -1, so that's going to change it to -25 hundredths. Then my last color I used was blue, just to help you guys see it. So my original x is -1 times -3. So my rule is 25 hundredths x, 25 hundredths times y. So 25 hundredths times the original x, which is -1, and 25 hundredths times my original y, which was -3, and 25 hundredths times 1 is 25 hundredths, but a positive times a negative is just a negative. So that's -25 hundredths. And then 25 hundredths times a -3, well, think about it. 25 cents, think about 3/4. 3 times 25 is 75 cents, but a positive times a negative is negative. But you can always use your calculator to double check that. So these are your new ordered pairs. So basically, you could take these and graph them and see from your original ordered pairs to your new ordered pairs that picture is going to shrink down. Okay, so I know there's a lot of information going on over here and all of that work to show you, but if it's asking for the rule, you're going to put your scale factor in front of x and your scale factor in front of the y. So your rules are different because our dilations were different. But using that rule to figure out those ordered pairs. Basically, once you know the scale factor, you're just multiplying your original ordered pairs to get to your new ones. Okay? Again, let us know if you need any help, and good luck.